You cannot remember what we have done yesterday. Anyone? Huh? Examples of family, okay? That was the last topic.
Yes, sir.
Okay, fine. So let us start with this PENTIUM processor family. So I think you remember that yesterday I have said that in chapter number 3, we are going to discuss about the PENTIUM processor. Why we are going to discuss about the PENTIUM processor? Because in chapter number 4 or chapter number 4, 5, 6, the following chapters, those all chapters are related to coding, assembly language coding, and those coding is for the PENTIUM processor, which is a 6 types of processor. And I think you know that PENTIUM processor is manufactured by the Intel Corporation, right? So all of the Intel processor, they use their own architecture. So if you know how to do coding in one types of processor, you can do coding for the other types of processor as well. You just need to change a little bit. So, right? Because they are having the same architecture as we know that Intel architecture, right? In short, IA. That's why we need to know about the Intel processor and the architecture, the number of the register and the address, memory, location and everything very, very clearly. Otherwise, we cannot use them. Remember what we are going to know in this chapter, we are going to use the same knowledge of this chapter number 3 whenever you write code in chapter number 4, 5, 6, and 7. So it is better we know it very well. So let us see what is in this chapter. First of all, it is the it is the history. We know that it was in 1969. We know that already long time ago, and we also know that all the Intel microprocessor, they're using their own architecture, Intel architecture, which is in short is IA. Right? It was started 8080. After that, we have find 8086, 801, 862, 863, 864, 866, then PENTIUM processor like that. And the first architecture, Intel architecture, they used officially, it is 8086, way back in 1979. And then our first 32-bit microprocessor, it was 80386 and in 1985. And the very latest PENTIUM processor was first launched in 1993. Right. Let us check about this. Yesterday, I have told you that we don't need to memorize all the information here, but at least the processor name, register width, data bus width, and maximum address space. Okay, maximum address space means the maximum memory size. Maximum main memory size. This one is the width of the data bus, and we know that the width of the data bus and the width of the address bus, they are same. That's why we also need to know the data bus, size of the register inside the processor. Right, this is the register width. That means what is the size or width of the register inside the processor. Right. So this is the register width, and these three things is optional. Like the year it was launched, or the frequency it has. Frequency, you can see that it's written megahertz. That means in 1 second, how many tasks it can do. Right. Then the transistor, how many transistors we have? As you can see, it is millions. Nowadays, it's so many. PENTIUM 4 processor already have 42 million, but nowadays it has much more, 10 times higher almost. So these three columns, they are not mandatory, right? Optional. But the processor name serially, corresponding register width, data bus, and maximum address space. That is mandatory. So let us see. As we know, the first processor, it was 8080, but they have not included yet, which is 1969. So they use it for the other purpose. But Officially, they have launched first one, which is 8086. After that, 80286, 386, 486. And after that, it is not called 80586. They call it different name, which is called Pentium. Just the name. Pentium, right? Then Pentium Pro, 2, 3, 4. After that, can you remember the name after the Pentium 4 until today? After Pentium 4, what are the model name of Intel processor until today? Huh? The series. There are at least 3 to 4 new series we have after Pentium 4. Although we still can buy Pentium 4 because it was so popular. Still you can buy Pentium 4 processor from the market. It's available. It's that much popular. Although it was launched like 21 years ago. But they upgrade themselves, but still they use the name Pentium 4 because it was so popular. Still now it is popular. That's why still they're manufacturing. None of them are still manufactured yet. I mean now. They stopped the manufacturing process. But they continue this one. No one can remember any name after Pentium 4.
Code to what? Code to do, code
to duo.
And then
dual core.
Then Core i series. And before that, there was another series.
Core i series, yes. Core i3, Core i5, Core i7, and very recently Core i9 as well. So these are the most common processor series or model name we have after Pentium 4. I told you the book is written and is published in 2004, I think. That means it is 17 years old already. 2004, right? 2004, I guess. Anyway, so it's still now 15, 17 years old, this book. So they have not included the other one because the other processor is actually launched after 2004. So if you want to know the recent one, you can also just Google this title, the Pentium processor family. They will show you all of them. Fine. Please remember the name. You need to remember the name serially. 8086, 286, 386, 486, then Pentium Pro, 2, 3, and 4. After that, dual core, auto dual, and 4, 3, 5, 7, 9, whatever. Okay. The register width, we are going to discuss about the register because each of the processor has its own type of register. Based on the width of the register, they actually written in this way. All right. So as you can see, it's 16 and 32, most of them. The first two are 16, the rest of them are 32 because 80386 was the first processor which has a 32-bit address bus and data bus as well. As you can see, it is also 32-bit data bus. You can see that they introduced the first 32-bit processor is 80386. 80386, this one. First processor which has 32-bit processor. Okay, two important terms: 32-bit processor and 64-bit processor. Every time, or 32-bit software, 64-bit software. Very important terms. If you have a 32-bit processor, I hope you know why we call them 32-bit, because the address bus and the data bus, the width of the address bus and the data bus is 32-bit of that processor. That's why it's 32 bits. Their register size might be also 32. That means at a time, that processor can send or receive 32 bits at the same time. So let's say, for example, we have a 32-bit address, right? You have a 32-bit address. If your processor cannot read 32-bit at the same time, there is no point that you have a 32-bit address bus, right? So your processor should be able to read that 32-bit as well. Only then you can have a very good functionality. Otherwise, you have some other issues. So the processor can process 32-bit at the same time. That's the 32-bit processor. The processor can process or receive or transfer 64-bit at a time. That is the 64-bit processor. Okay.
Hello, sir. I am Alamina Kasi speaking. Sir, in the year 1978, the processor name was 8086.
It's not 8,000. Listen, Mr. Akash. It's not 8,000. It's 8.
Yes, sir. Okay. We have to pronunciate like that, right, sir?
8086. Yes.
Okay, sir. In here, like data bus, was 16. But why here maximum address space is only 1 MB, sir?
We have reason. We have reason. Let me tell you. Wait. Right. So, good question. Let me explain. Let me explain the 32 and 64-bit class, right? Faster, right? So, the processor, because these are the two assignment topic of your, and you remember that you have only 4 days left. So 32-bit processor, and it will be the question in the first term exam. So 32-bit processor, remember that those processors which can process 32-bit at the same time, right? 64-bit processor can process 64-bit at the same time. And if you have 32-bit processor, obviously your software environment, for example, your operating system, for example, your other software, system software, those all software needs to be also 32 bits. Then you can have a good match and you can work together nicely, smoothly, no problem. But if you have a 32-bit microprocessor, and then with the 32-bit of data bus and address bus and everything, and for example, you want to install 64-bit software or operating system. Do you think it is possible? It is not possible, because you cannot, your software will give you 64-bit at the same time. Or the processor or the software wants 64-bit at a time, but your processor can provide you only 32-bit. So it's a mismatch. That's why in 32-bit system, if you want to install 64-bit, you cannot do that. On the other way, if you have a 64-bit microprocessor, and if you want to install a 32-bit software, there are some mechanism by which you can maybe install on the backward option. In that case, you might be installed, but you might have some problem as well. But during the installation of any software or any environment, they will ask you and warn you that you are going to do this. Some of the software cannot install, some of the software, they have backward compatibility. It is called backward compatibility. That means whatever you have used in the previous version, you can use in the forward version as well. But you cannot use the forward version in the previous version, right? It is some of the components are not forward compatible. For example, you cannot install a system because it is not forward compatible. But you might install a 32-bit software into 64-bit system because it was backward compatible. Okay, it's called forward compatible and backward compatible. Depends on which software you are using. That's why most of the software, good software, they have two versions, 32-bit version and 64-bit version. Previously, I'm talking about previously. Still now, we have so many devices and processors which still have 32-bit system. Nowadays, most of the operating system, most of the devices, and most of the processor are now 64-bit. Because if you still, let's say you have a very old laptop, that old laptop might have a 32-bit microprocessor. Obviously, you install a 32-bit operating system. Right, so in that case, some of them still we have, but If you have very recent one, let's say you bought it like 5 years ago maximum, then it would be 64-bit, right? So please think about this one as well, forward compatible and backward compatible. Similar as though if you think about the forward and backward compatible, because whenever you use, let's say Microsoft Word 2016 or 19, Microsoft Word 2016-19 can read Microsoft Word 2003 version, which is the doc version. So it is backward compatible, and it is also supported docx format. But if you use 2003, it will not open your docx version, which is the current version. That is the best example. If you use Microsoft 2003, you cannot open docx version, docx format of the documents because it is the forward version. But if you are using my 2019, let's say my one is 2019, I easily can open any documents which was created in 2003 and long before, which is the doc version. So it's called backward compatible. Most of the time, most of the software compatible that is match open can operate the previous old version, which is important. Otherwise, all your previous version will be vanished. So that is the difference, and that is the features you just mentioned about what? About 32-bit microprocessor and 64-bit microprocessor. Okay, make sure we know it very well. There are so many other explanations. I'm just giving you very little and general one which we need. Please read more about the 64-bit and 32-bit microprocessor. Okay, because it's a very, very, very common question in your Viva and all of the exam as well. And you have also the assignment. Please. Okay. And in the real life also, it is really, really necessary whenever you try to install it, whenever you try to buy a new device, whenever you think about how we can improve your performance of your system, so it is necessary. Anyway, so now let us discuss about the other one. There it is some mismatch. You were asking Mr. Akash that why 16-bit we have 1 mega. So
Yes,
the answer is check the address bus of this. Let me show you the address bus. The address bus of this 8086 is actually different, not about the system bus. I mean the data bus. Generally, we have the same size. Let me show you from the book. It is not the same size. That's why it is 1 mega. I think it is 20-bit long, our address bus. So yes, 20-bit long. That's the size of the data bus, and the size of the address bus is not same. Another example is this one. Look, its data bus is not this one. This one. Its data bus is 64, but we have 64 GB. Remember that it is data bus, not address bus. They are all 32-bit processor. So we know that 32-bit processor can support maximum 4 GB. Then how come it is 64 GB? That is another problem. Remember, this is the data bus, not the address bus. That is another confusion. First confusion because Akash was asking that why it is 16 and why it is 1 mega. The answer is the size of the address bus is actually 20 bit, whereas our data bus is 16 bit. Here, our address bus is 36 bits, not 32 bit, 36 bits. And the address bus and the data bus is 64 or 128 and something. So previously in chapter number 2, we have said, and I have given you this information, that generally the size of the data bus is equal to the size of the address bus, but there are some exceptions. These are the exceptions. Okay, that is the reason. Let me show you.
Sir, there are another confusion, sir. After the Pentium 4 processor, sir, Microsoft company had their own computer system that was called Mac, sir. In Mac, the register read was 32 and but data bus width was 64, but they have maximum space of 124 GB. How it is possible, sir?
1.4 GB, which one?
Sir, after the Pentium 4 processor, okay, Microsoft company has their own version of computer. Its name was Mac computer, sir.
Microsoft.
They have, yes, sir.
Mac computer.
Yes, sir.
Really?
Yes, sir. They launched Mac, sir, with their operating system of Windows, sir. But in Mac computer, the maximum address space was 124 GB, sir.
Maximum 124.
Yes, sir. How that works? Sir?
Might be, because we are discussing about Intel architecture. All right.
Yes,
we are discussing about Intel architecture, so maybe the Intel architecture and their processor architecture may not be same.
Yes.
For example, the Apple, they have their own microprocessor.
Yes,
Bionic chip, right?
Yes,
A9, A10, A11, A12. They also have different architecture of their processor as well.
Yes.
For example, your Samsung Exon microprocessor, they also have different architecture. For example, the AMD microprocessor, they have their own architecture as well. So different manufacturing company has different architecture to manufacture their own microprocessor. That's why several times I have mentioned that we are talking about Intel architecture, only the Intel architecture, because Intel microprocessor are the most common one. All right.
Yes.
So if we want to write code on the other types of manufacturer, we also need to know their architecture as well to do the code correctly.
Okay, sir.
All right. So good question. Good question. The different company has different. So that is actually the explanation, and they have different architecture. That's why every time you will read the book from the following chapters, many times they're using these terms, IA family, IA architecture. Most of the time they mention this one, IA architecture. Every time they mention it, because the way they have produced or manufactured the different types of microprocessors, they follow one architecture, specific architecture.
Yes.
Right? Let's say you want to write a code. Let's say you want to write a code for 80486. So you need to know which architecture they have used. Obviously, it's IA architecture. You need to know the IA architecture and then write the code. If you want to code in the name you have said, I don't know that one. So you have to know their architecture, then you can write the code in their way. All right. So why we choose, you may ask me then why we choose Intel architecture? We choose Intel architecture because the Intel microprocessor is the most popular and widely used. That's why. Let's say more than 70% PC are using Intel microprocessor. Although it is decreasing nowadays, but most of the microprocessor, wherever you go, most of the PC, I mean, out of 40 students here, I think all of you has Intel processor.
Yes, sir.
I think there is no one who has the AMD processor or Mac Bionic chip processor. If you are using,
I have a Ryzen processor.
Oh, you have the Ryzen processor. Very good. So we found one. Very good. So it's very few. That's why I'm asking. That's why we are actually using or studying this architecture, because it's very common. Fine. So your first question was, look, the data bus was 16-bit. Look at the size of the address bus. Here, this is your answer.
Yes, sir. This is the problem, sir. We have to.
Not a problem. This is not a problem. This is according to the architecture. All right. This is according to the architecture. So it says that the data bus is 16-bit. It's clearly written here 16-bit, but the address bus is 20-bit. All All right, so that's why our maximum memory size we can use here 1 megabyte. Okay, so that is the one of the exceptions. We have another exceptions here, which is 80 Pentium processor maybe. Pentium processor maybe. Let me check. Pentium Pro. Yes, Pentium Pro. In the Pentium Pro processor is still 32-bit. Remember, all of them are 32-bit processor. All of them. Although the data bus is 64, some of the data bus also you can see that is written. Internally, it has 120 and 256 wide data path to speed the internal speed. Although, however, the Pentium instruction set supports 32-bit operands. So it's actually contradictory. Sometimes they're using some booster for internal purpose. So from one position to another position, sometimes they have the maximum size of the 64, but the processor they have written here, and because they have only 32-bit operands. That is one confusion. Another exception is Pentium Pro. Look at the Pentium Pro, this one. If they are all 32-bit microprocessor, how come they have 64 gigabit of address bus? Remember, these are not address space, these are data. All of them are 32-bit from here. Then how come they support 64-bit? Answer is the address bus has been expanded to 36 bits. So,
Yes, sir.
so if you have 32-bit address, then you can have maximum 4 GB, right? So if you do a little bit of calculation, for 32-bit, you have 4 GB. For 33-bit, 8 GB, right? 34, 16 GB, and 36, like that, you have maximum 64 GB. That is the reason we have 64 GB. Because of this reason. Because the address bus, they have expanded from 32 to 36. So that which gives an address space of 64 GB. That is the reason. So different model have their different technique or different way to increase the performance and ability. There are some other also which they have used. For example, Pentium processor can do multitasking. Pentium Pro processor can do multitasking. It can execute 3 instructions per clock cycle. Look, it starts with the multitasking. Previously, in the system clock slide, we have said that each clock cycle, the processor can do 1 task or process 1 data, right? That is the single task processor. From Pentium Pro processor, advanced technology, which is multitasking, each clock cycle can execute 3 instructions. That means it will increase the ability to execute the instructions. Fine? All right, do you understand? So different processor has slightly different upgraded feature. So if you just think about from 8086, 8088, then you can see that step by step they increase their functionality. Fine. So let me tell you about the cache memory. I think I have shown a look at my cache mega, and L3 cache is 9 mega. and my one is I59600. It's of course Intel. So I have three cache, three level of cache, level 1, level 2, level 3. Three level of cache with this size. If you think about the previous processor, for example, 80486 or 80386, they have L1, it has 4 kilobyte of L1 cache. Compared to my one,
A lot of difference, sir.
it is 384, but here L1 is 8 kilo. I'm just giving you some comparison. Furthermore, supported for the L2 cache and multi-processor has been added. Look at the next version, Pentium series. They have 4 kilo of L1 cache, and I think they have L2 as well. And another 8 kilo for the instruction. Of course, they have actually two, one for the data, one for the instruction. For Pentium Pro processor,
Last slide.
they have L2 as well. Look, 256 kilobyte of L2 cache. So they have introduced another level of cache, whereas in the my one, 1.5 mega. So if you go further, you actually can see L1, L2, L3. Look, in Pentium 2 processor, L1 has increased to 16. So each of the processor, if you have launched a new one, they added some new features. They expanded the ability. They expanded the cache size. They expanded the address bus and the data bus so that the process until my processor, how is the progress is happening. And remember, all of them, whatever we have seen so far, all of them have the same architecture, Intel architecture IA. So if you understand 8086, you can understand my Core i5 9th generation microprocessor as well. You just need to know what is how many registers we have, what are the names, what are the cache size, how much cache size you are going to use. So if you just upgrade yourself, everything else is same. Okay, that's why we need to know the history. You might thinking then what is the reason we are talking about the history of the microprocessor? That is the reason. Right, so you have a very good understanding how they have upgraded and what is the current position right now. Fine, any questions so far? Otherwise, we are going to do the next topic. Our next topic is the register of the Intel processor. So please, my suggestion is, this book I told you, written very nicely. So it is better you read it from here, the Pentium processor family. They have written very nicely and easy to understand. If you want to know more about each of the processor, you can just Google it. And the good thing is, each of the one paragraph they have written for one processor. 8086, 286, 386, 486, Pentium processor, Pentium Pro processor, then 2, then 3, and then of course the 4. Okay, so you can read it from here, or just Google it, or you can just go to the Wikipedia. It's also best way to know about this processor. Fine, it is mandatory by the way, so know this. Okay, let us go to the most important part of this chapter is about the register of the Pentium processor. I told you that based on this information of the data, we are going to write code in chapter number 4. We need to memorize some of the things. We need to understand some of the things of the register as well. Otherwise, it will be difficult for you to write the code, assembly language, for the Pentium processor. So in the Pentium processor, we have several types of registers. All right. Generally, I think you remember that previously we have said there are two types of registers: general and special purpose. Special purpose is again divided into two types: control and the segment. So in general, we can say that the Pentium processor has three different types of register: general, control, and segment. Or you can say control and segment. Okay, these are the system or special purpose register, and this is the general purpose register. So the general purpose register also can be divided into three different parts: data and pointer and index register. Let us see about the first one, data register. So it is better we look at the picture. These are the data register. Each of the type has a very good images. I think it is better we just look at the images. Much better, an easier way to understand. So this is the data register. As you can see, the width of the data register is 32-bit long, 0 to 31, 32-bit long. Okay, and we have four. We have four data register which is 32-bit long. The names are very simple: EAX, EBX, ECX, and EDX. Extended AX, extended BX, extended CS, and extended DX. Generally, we have AX, BX, CX, and DX because AX means accumulator, BX means base, CX means counter, and D means data. That means different register. We use it for different purpose. These are the purpose. So this 30, let me finish, then you ask.
Okay, sir.
In this 32-bit register, we can divide in three different ways. First of all, we can use this entire 32-bit register at a time. If you use the entire 32-bit at a time, the name of that register will be EAX. If you use the first 16-bit of the processor, register, the name will be AX. Same way, BX, CX, and DX, the first 16-bit from 0 to 15. If you want to use the first 8-bit of the processor or the second 8-bit of the processor, you also can do that. In that case, you have AL and AH. AL means, of course, the lower part, accumulator lower part. AH means the higher part, low and high, low and high. Same way, AL, BL, CL, and DL, AH, BH, CH, and DH. Individually, you can use it. So this 32-bit data register of Pentium processor, you can use it in three different ways. Either you can use it 8-bit by 8-bit, or you can use it the first 16-bit, or you can use the entire 32-bit, up to you. Whenever you use a different way, the name of the register will be also different. Simple. If you are using the 8-bit, either AL or AH. If you're using entire one, then AX. Entire 16-bit, first 16-bit, AX. If you use the full 32-bit, then it is EAX. And it's the same for the others as well. And each of the register has their own responsibility. Generally, the general responsibility by which you can identify the register. Okay, it is written here. It's the same thing actually written here. Lower half and saying whatever we have discussed so far. Fine, so that is our data register. What is the question?
Sir, Johra Akhtar mean waiting in waiting room.
Who?
Sir, Johra Akhtar mean. Sir, she faces network problem. That's why she disconnected.
She was present, sir. She's informed already, sir.
There is not.
She is waiting.
She is not in the waiting room. Mr. Moinul Islam, who is late? There's no Johra Akhtar. Okay, anyway. So any question about the data register? And do you understand how we are going to use the data register? Remember, we are going to use the name, all the name of the data register whenever we are going to do the code, like addition, subtraction, multiplication, division. We are going to use them based on the size we need. Remember, again, please, based on the size you need, you can use or choose either one of them. If you need a bigger number, if you want to store a bigger number, if you think your result is bigger, then you can use the bigger part of the register. If you have a smaller number, you must use the smaller register. Just think about it. We have only 4 data register, which is 32-bit long. We don't have unlimited, right? So we have to use our register very, very accurately. Otherwise, your system will be slow, right? We don't have thousands of register. We have very small amount of register inside our processor. So do you understand the data register? Any question?
No, sir, understand.
Well, fine. Still, if you have any questions, so please read it from the book or from the slide. I think it is nice where they have given. Let me show you the another 2 types actually. The pointer and the index. And the pointer and the index register. Although we are saying that 2 types, they have written in the one. We can say is there are 2 different. So one is the index register, another one is the pointer register. So both of them are 32-bit. Index and pointer register, both of them are 32-bit long. Unlike the data register, we cannot use them like 8-bit, 8-bit. We can use it either 16-bit, first 16-bit, or entire 32-bit. Okay, and each we have only 2 index register, 2 pointer register. Data register, we have 4. Here we have only 2. In data register, we can use 8-bit, 8-bit, 16-bit, or 32-bit. Here, either we use 16-bit or 32-bit total one. Those are the differences. So the 2 they are divided for different purpose. For example, source, you can store the source index into here. SI means source index, or destination index, DI. If your address is 16-bit long, you can store it. If you need more than 16-bit, you can use entire 16-bit, which is EDI, extended DI. ESI, extended SI. SI means source index. Fine, so these are the index register. We have also the pointer register. Generally, the source index and destination, these are using for the string operation. I think for the string operation, most of the time we use the index register for the string operation. Check the book. I think it is for the string operation. For the pointer register, we also have 2 pointer register, same as the previous one. One is for the stack pointer, another one is for the base pointer. Okay. We are going to discuss the stack operation of the PENTIUM processor in chapter 6, maybe after the midterm. Okay, after the first term, sorry, during the midterm. So here again, SP means stack pointer, BP means base pointer for the stack operation. So if you need more address space, then we need to use 32-bit long, which is the name is ESP and EBP. Just remember, pointer register is using for the stack operation. Index register is using for the string operation. Please check the book. They have written in a nice way. It's all right. We don't have time. Check it. Any question regarding the pointer and index register?
Sir,
No.
in the index or pointer register, we have 32 bit, but we are using 31. Why is that, sir?
No. 0 to 31.
Oh, okay. Clear, sir. Yes, sir. Clear.
All right. So last types of register. Let us see the last type of register, which is called control register. After this, we will finish our class. So the last type of register is called control register. Control register. Look at the. I always prefer the image. This is the control register. The control register is divided into two parts. One is the flag register, 32-bit. Another one is the instruction pointer register, which is also 32-bit long. So the control register have two types or two parts or classified by two. One is the flag register. Okay, flag register means if you are using fast 16-bit, that is called flags. If you are using full 32-bit, it's called E flag, extended flag. Same as the previous one. So we have this flag register. We have another type of register which is called the instruction pointer. Same. IP means instruction pointer. So if you why we use it? Instruction pointer, we use it to track the location of the next instruction which needs to be executed. I think you know that after executing one instruction, the processor needs to know which one is the next instruction to be executed. So the processor also needs to know in which memory location it is stored. So the instruction pointer register, IP, actually stores the memory address of the next instruction. So it will be always easier and faster for the processor that, okay, I know which processor is going to be executed next. So the IP, instruction pointer, save that memory location. So if that memory location is 16-bit long, you store it into the IP register. If it is 32-bit long, then you can use it in the EIP register, extended instruction pointer. Now think about the flag register. We almost finished, that is the last one. The flag register, so if we use 16-bit, then we can use flags. If you use 32-bit, then it's called extended flag, in short, E flag. There are three types of flag. You can see that, three types of flag. 6 types of status flag, this one. Flags actually indicates the status of the instruction or the status of the execution. All right? So we are using these types of flag to identify the status of the instruction or the execution. So as I said, there are 3 types of flag, 6 types of status flag, 1 type of control flag, and 10 types of system flag. Remember the number, 6 types of status flag. These are the 6 types. We are going to use some of the flag whenever we are going to do the multiplication and division in chapter number 7, like the carry flag, parity flag, overflow flag. Okay, so these are the status flag, 6 types, 1 control flag, and there are 10 system flag. It is not mandatory to remember all these flags, but at least you remember some of it as an example. If I ask you, can you give me 1 or 2 examples of status flag? So you should tell me carry flag, parity flag, overflow flag. Can you tell me at least 1 or 2 examples of the system flag? You can say the ID flag or the resume flag, the nested flag, any 2 or 3 you can remember. So I suggest you please at least try to remember 2 names. Whenever you are going to do your microprocessor course, you are going to learn every bit of it into that course. This is not a microprocessor course, so we are not going to describe that much. We are just going to use them. But if you want to know more about these flags and register and everything, please refer to the microprocessor course. All right, fine. And the good news is from the next year, maybe, this assembly language course and microprocessor course will be combined together. It will be much better. So because whenever we do writing code, so we don't need to refer to the, okay, you can learn this one from the other course. Or I don't need to explain that much. Or already it should be inside the same course. It will be much, much better, right? Okay, that's a different story. It's not in your, not in your business. Anyway, so that is the control flag, right? Flag register and instruction pointer or IP register. That is the last type of, oh, we shall try another one. I forget this one, segment register. Anyway, not today actually. We are going to discuss it in the next class. Any question until this point? I suggest you please study at home. Otherwise, you actually have less than 1 week. You have less than 1 week for your first term exam. I think your first term exam is on 5th. So you have less than 1 week. You have to do the assignment as well. So you have very, very short time. So please don't waste time. Please study at home. It is better whenever I discuss some topic like the register I have discussed, the processor I have discussed, study tonight. And you can remember, you can understand. Don't leave it at the end at the end of the time. Okay? Any questions so far? If there is no question, let me give you the attendance. Maximum time for that. Our class is until 2:10, right? It's not 2:15.
Yes, sir.
It's
210.
210, 210.
Oh, sorry. Most of the time I was thinking it was 2:15. That's why. Yeah. Section B. Your section B, right? Yes. Every time I make the same mistake. My intelligence level is very poor. All right, CSC 197 section C. Mr. Shakil Ahmed, please respond. Yeah, Mominur Rahman. Mominur Rahman. Saidul Islam.
Yes, sir.
Moinul Islam.